We had a batch of questions that were asked from section 1.5. I believe it was like 27 through 40 something. So I thought I'd just go through and do 4 of these that hopefully would give you a push in the right direction, and hopefully you guys would understand what was going on and figure out from there. So the first one is a pretty straightforward inverse trig problem. And as I think you guys probably deduced, this is one you're supposed to be able to do without a calculator, the inverse cosine of 1. The first thing I need to make sure that everybody understands is that there's a difference between an inverse cosine question and a straightforward trig question such as cosine. If I were to ask you a question such as the cosine of pi over 6, now I'm hoping without a great deal of difficulty you guys could think about this for a minute and come up with an answer of the square root of 3 over 2. What's important that everybody understands though is that when I ask a trig question, this number right here, the pi over 6, is the angle. You take the sine or the cosine or the tangent of an angle, and the answer you come up with simply is what we call a ratio. Now, if I spun that around a little bit, I could ask you the question, what is the inverse cosine of the square root of 3 over 2? And the answer to that question would be pi over 6. Now, in this case, when we're talking about inverse trig, inverse sine, inverse cosine, or inverse tangent, the number we're taking the inverse cosine of, that is now the ratio, and the answer to an inverse trig problem is the angle. Now the reason for that, guys, is because effectively what we're doing right here is we're taking an equation like this one that we have right here, and I'm going to take the inverse cosine of both the left and the right. Remember, you can do anything you want to both sides of an equation as long as you do the same thing. Although I'll talk more about that in a second, it can be a little bit tricky with trig. Inverse cosine and regular cosine, as the names suggest, are inverse operations of one another. They cancel each other out, and so we just end up with pi over 6 now from the left side. And on the right side, inverse cosine of root 3 over 2. And you'll notice that this statement now is identical to this statement we made here just a moment ago. Both of these statements here are true, and it's because of that concept that you can take the inverse cosine of both sides. So, with all that being said, everybody, here's what's going on in problem number 27. They're asking you for the inverse cosine of 1. So what we need to realize here is that 1 is the ratio that they're giving us, and the answer that we give them is going to be an angle somewhere here on the unit circle. Now, what we're looking for specifically is the one spot on the unit circle, although we have to be careful, there's technically 2, where your cosine value is equal to 1. Well, the easiest thing for me anyway to think about on problems like this is to remember here that we want to know the cosine of some angle out there should equal 1. And we need to remember that our XYR definition of cosine is x over r. However, if we think of this as a unit circle, over here on the right, the one important thing we need to remember about a unit circle is that your radius is equal to 1. So back over here to where I just wrote x over r, if we know the radius is 1, then our cosine value is simply our x-coordinate. So this question is asking us where on this unit circle is cosine or your x-coordinate equal to 1. And if we remember, guys, this is a unit circle with a radius of 1. There is only one spot on this unit circle where the x-coordinate of your point is equal to 1, and that is this spot right over here. That's the ordered pair 1, 0, and the angle that gets us to that point right there is 0 radians. Now, technically, the other answer to this question could have been 2 pi as well. We could have made one complete loop around the unit circle, and I guess by that rationale, we could have made 2 complete loops, or 3 complete loops, and so on and so forth. But when we're talking about inverse cosine, the answer to that one can only be in the first or the second quadrant. That's something I'm going to explain a little bit more of in just a few minutes, so try to stay with me when we get to that spot. But no need to make this problem harder than it is. The first and most obvious angle that has a cosine value equal to 1 is 0. Okay, so that's problem number 27. Let's take a look at, let's see, the next one I wanted to do, was the one right after that, problem number 28. Another pretty straightforward trig question. They're asking for the inverse sine of 1/2. So we need to remember that 1/2, nope, I'm doing that wrong already, that 1/2 is not an angle, it is the ratio. And the answer to our problem here is going to be an angle. We're looking for an angle somewhere on the unit circle here that has a y coordinate. Now, let me explain that a little bit more, or a sine value equal to 1/2. Okay, so to explain what I started to just say there a second ago, sine, if we remember, the definition of sine is y over r. And if we're on a unit circle with a radius of 1, the radius is just 1, so sine is really just y, and we want to know where your y coordinate is equal to 1/2. Now, I explain a problem like this differently than I think a lot of other teachers out there do. I kind of look at things geometrically. I want to know where on this unit circle has a y coordinate equal to 1/2. So thinking about my y-axis right here, I know that right up here, my y coordinate is 1. That would be at pi over 2. Right down here at 3 pi over 2, my y coordinate is -1. And of course, right there, guys, our y value is 0. Now, 1/2 is obviously halfway between 0 and +1. So what I like to do is I like to draw the horizontal line y equals 1/2 on that unit circle. So whatever this equation was, I just graph it right there. And I ask myself then, at what points on the unit circle is the y coordinate equal to 1/2? Or another way to look at that, where does that line that I just drew cross the unit circle? It happens twice. Once right here in the first quadrant, once right here in the second quadrant. And if I go ahead and make triangles out of this kind of is a test of how good of a drawing you're doing here. Mine isn't very good. These two triangles should be congruent to each other, but I did a pretty lousy job. Anyway, I'm hoping your graph looks better than mine, and I'm hoping you guys can tell me where we are now. To get a y coordinate of 1/2 and a radius of 1, that would give us an x coordinate, not really relevant here, of root 3 over 2. What angle is this right there that gets us to this magic point? The answer to that, everybody, is going to be pi over 6. Now, as I said a moment ago, there's actually a second answer to that question. This angle right here, where theta is equal to 5 pi over 6, also has a y value or a sine value equal to 1/2. But for reasons I'll explain on the next problem here, that one right there, the only answers that we're looking for to an inverse sine problem are from -pi over 2 to +pi over 2. We're looking in the fourth quadrant and the first quadrant, so pi over 6 is the answer we're looking for to that one. Okay, now things start to get maybe just a little bit more interesting right here as we start to look at 33, and then 37 is where things get really interesting. Okay, so 33 is where they start throwing some stuff at you here that's going to make you think a little bit. They're asking you here, what is the inverse sine of pi over 3? So they're asking you for an inverse trig ratio here of a regular trig ratio, and that means that pi over 3, they're back to giving us an angle, not a ratio now. But the overall question they're asking us, or the last question they're asking us, is inverse sine. That means that my answer over here, in that case right there, is most likely going to be an angle as well. So what's going on here? We want to know where on the unit circle sine is equal to pi over 3. I should say, what is the sine at pi over 3, and then where on the unit circle does that happen? Okay, the quick explanation to this problem, this is the way you want to try to approach these if it works, is to recognize here that inverse sine and regular sine are inverse operations of one another. So the first thing that should occur to you here, and sometimes it works, although sometimes it doesn't, maybe inverse sine and regular sine just cancel each other out and leave us with an answer here of pi over 3. Now we could go a little slower to find out if that's right. I believe it actually works in this case. Let's try this again. Inverse sine of, let's think about the sine of pi over 3. Now if you guys have this memorized, great. And if not, we could work through it. I'll try to draw a little better circle this time. Pi over 3 is going to be a 60-degree reference angle here in the first quadrant, looking something like that. Okay, and that gives us a 30, 60, 90 triangle that's standing up. Sine is your y coordinate here. which is root 3 over 2. So the sine of pi over 3 is the square root of 3 divided by 2. Now the question becomes, what angle, again, in the fourth or the first quadrant, there's only one answer to the question when you look at it that way, what angle in the fourth or first quadrant has a sine value equal to root 3 over 2? Well, that's the same angle we were just dealing with right over here, and yeah, the answer is pi over 3. So I probably just gave you what felt like a really long-winded explanation to a really simple problem. Inverse sine and sine cancel each other out, and it just leaves you with the angle of pi over 3. Now, if that made sense to you, then you're probably going to look at 37 and say, oh, inverse tangent and tangent cancel out, and the answer is 3 pi over 4. And you probably got pretty upset then when you looked in the back of the book and realized that that was not the right answer. And the answer, if I'm not mistaken, is negative pi over 4. So how in the world did they get from what I thought was the right answer to this one here? Well, we got to slow our roll here just a little bit and think a little bit more carefully about some of these rules. So if you guys don't know these from last year in pre-calc, it wouldn't be a terrible idea for you guys to write this down. Anytime you are being asked to come up with the inverse sine of a particular ratio here, so let's just leave that as inverse sine. What you guys need to know here is that theta can be any angle for inverse sine in between negative pi over 2 is less than or equal to theta, which in turn would be less than or equal to positive pi over 2. Or another way to look at it, that means that theta can be in quadrant 1 or it could be in quadrant 4. Those are the only two quadrants where the answer to an inverse sine problem can come from. And that's why, if I go back to problem 33, this was an inverse sine problem. The answer I wanted to give them was pi over 3, and sure enough, pi over 3 is in this range right here. So that was an acceptable answer. Inverse cosine is kind of a weird one, guys. This one goes from 0, is less than or equal to theta, which is less than or equal to pi. And that means that we are dealing here for inverse cosine in quadrant 1 or in quadrant 2. Okay? And the last one right here, like a lot of other things out there in the world, tangent tends to follow the same pattern as sine. For example, they're both odd functions, whereas cosine is even. So the domain here, I really should say the range for inverse tangent, would be the same as sine. Negative pi over 2 is less than or equal to theta, which is less than or equal to positive pi over 2. And once again, that means that we are looking either in quadrant 1 or in quadrant 4 for our answer. So if you don't know all of these things right here, you probably better write them down, and you probably ought to have those memorized before we take a quiz or a test covering this material. So now let's go back to 37 and let's talk about why the answer is not 3 pi over 4. Quite simply, this is an inverse tangent question, and the answer of 3 pi over 4, if I go forward to the next slide, 3 pi over 4 is not in this range right here. It is bigger than pi over 2. So we're looking for an angle in between negative pi over 2 and positive pi over 2 that has a tangent value equal to the tangent of 3 pi over 4. This one we're going to have to slow down a little bit here, guys, and we're going to have to think about this one a little bit harder. So let's draw ourselves a unit circle here. Again, I'll try to get this relatively symmetric. And I need to get rid of this answer here, because I'm pretty sure that's not right. And we're going to focus on coming up with the tangent of 3 pi over 4. So hopefully you've thought about this already. 3 pi over 4 is a 45, 45, 90 triangle that's located in the second quadrant. So it's going to be located right here. That's 3 pi over 4. And your triangle, as we just said, is a 45, 45, 90 that looks something like this. Now, let's go ahead and get things right here. The hypotenuse is 1, and then in this case, both of the legs have a length of root 2 over 2, or you could have left those as 1 over root 2. The x-coordinate is going to be negative, though, negative root 2 over 2, because as we said, we are in the second quadrant here where the x-coordinate is negative. So, let me just break this down. This problem now becomes inverse tangent of, and we just said here, or actually we didn't finish it up, the tangent of this particular angle would be your opposite leg, your y-coordinate, over your adjacent leg, your x-coordinate. Notice those numbers have the same absolute value, they're just opposites. So root 2 over 2 divided by negative root 2 over 2 is going to equal -1. The tangent of 3 pi over 4 is -1. Now it's a whole new problem. Now the problem is, what angle has a tangent of -1? But I actually should be more specific. What angle in this range right here, from -pi/2 to +pi/2, has a tangent of -1? So I'm not looking in the second quadrant for my answer, guys. I'm looking in these two quadrants here for inverse tangent, the first and the fourth. Well, I'm hoping you guys realize it can't be a first quadrant angle because tangent in the first quadrant is always positive. We need it to be negative. So we've got to be looking instead down into the fourth quadrant, and the only angle down in the fourth quadrant where the x and the y values would be equal to each other would be this angle right over here, right? Which is going to be -pi/4. So that is the answer to this problem, -pi/4. And the reason it's not 3 pi/4 is because the range of an inverse tangent question is -pi/2 is less than or equal to theta, which is less than or equal to +pi/2. We're only looking in the first and fourth quadrant. 3 pi/4 is not in this range, so we had to come up with the only other angle that is in this range that had a tangent value equal to -1. We really should be careful here, guys, because the answer to this question right here, inverse tangent of -1, means what angle has a tangent value of -1? There's an infinite number of answers to that question. However, there's only one answer to that question that's in this particular range. And that's actually the purpose of all three of these ranges here. Every value of sine from -1 to +1 occurs exactly once, but not more than once, in that range there. Every possible conceivable value of cosine, which also goes from -1 to 1, occurs once, but not more than once, in that range there. And every conceivable possible value of tangent, which is actually an infinite range. Tangent can go down to -infinity and all the way up to +infinity, but each one of those values occurs exactly once, but not more than once, in this range here from -pi/2 to +pi/2. So that's kind of a nutshell explanation right there about inverse trig functions. Hopefully that makes a little bit of sense. Good luck, everybody.